today will be about basic trigonometric identities and equations. So I will ask you a question. Okay, Carina, what are the basic trigonometric equations? Tangent, sine, cosine, cosecant, secant. Okay, so those are the trigonometric identities. So the objectives for this lesson is that you as a student will verify a trigonometric identity numerically using the technology. So that is why I let you do the graphing calculator yesterday, so that you could verify this one using the technology. And the second one is explores reciprocal, quotient, and Pythagorean identities. So we will be learning these identities. Okay. So we will have first the key terms. So we need to have the key terms because this is very important. So that you could you may just listen to me. I will give you the handouts. Right? There is. Right. So the term identity from your own words. What is identity? Alex, could you read this one? Okay, it means it is true, not false. Okay, so like say for example, when we say Senna, what is your identity? What are the identity that we can say this is Senna? She's a girl, of course. What else? She's wearing this one, and that is Senna. Okay, that is identity. Okay, no one can wear that one except Carina. Okay, so that is the other meaning for identity. Alright? Questions? Another key terms is trigonometric identities. So these are equations that are true for right angle. What do you mean by right angle? 90 degrees. So it should be 90 degrees. Okay? Okay, this one. So as you can see here in the triangle, it should be 90 degrees. So if you're going to, if you remember when you were in pre-cal 11, I guess, or 12, so this is the adjacent, this is the opposite, and this is the hypotenuse. And you remember about Sukatua, right? Okay? Where S meaning sine, and that would be opposite over hypotenuse. So this one opposite over H. K meaning cosine, adjacent over hypotenuse, and T is tangent is equal to opposite over adjacent. Okay, so here. Questions? So far? So this is we call right triangle, meaning it is 90 degrees. Right? So another question. Why are you so busy with your phone? Okay? No questions? No? Nick, you have questions? No. So, did you remember this one? Yes. What is this? Unit circle. Okay. So, remember when we have the trigonometric ratios for this one? So, we could have sine would be
sine equals y over
y over r, right? But since this is a unit circle, r is equal to 1. So sine theta is equal to 1. Follow? How about cosine theta? Nick, what's that to be? X over r, right? So r is equal to 1. So that is why we have cosine theta is equal to x. Hello? So this triangle equation is taken from the unit circle. So Achina, how about tangent? So y over x. And we know that y is equal to sine theta over x is cosine theta. So that is why we could have tangent theta now. So we call this one as identity. An identity. Okay, what is identity? Hello? Questions? So far? Okay. Can I go to the next slide? Okay. So that is why we have here the trigonometric identities. Okay, I'll be giving you the trigonometric identities. So these are a lot, but we will discuss this one by one. So we have the quotient. So we call this one as quotient identities. Reciprocal identities is this one. You already know this one with our lesson, right? Sine theta is 1 over cosecant theta, cosine theta is 1 over secant, and tangent is 1 over cotangent. Questions? Why are you so lonely? Okay. Next, as you can see in your paper, we have the formula. We have the quotient, we have the reciprocal, and we know how we derive these Pythagorean identities. The third one. Okay? So here, do you remember the unit circle, right? Yeah. What is the equation of unit circle? Alex? Remember? 1 what? I know that is equal to 1. So it is?
36 degrees 1.
No. Can you do?
Y squared plus 6 squared.
Oh, yeah.
That's it. So x squared plus y squared is equal to 1. Okay? This one. Right? So having the identities of Pythagorean theorem. So x meaning cosine, right?
Yes.
And y is sine. Right? So that is why x squared is sine squared, right?
Yes.
Y squared, no.
Oh, yes. It's squared.
X squared is cosine squared, y squared is sine squared is equal to 1. That is why in your third, we have sine squared, cosine squared is equal to 1. Okay? So you could interchange this one so you could make it different. Alright? Questions? No questions. Next, how did we have the other Pythagorean identities? So try to divide by cosine squared. So this is the given, right? This is the first one.
Yes.
We divide it by cosine squared, so what happened? So it becomes tangent squared plus 1 is equal to secant squared theta. So you see it in the identities? So that's it. Right? So that is how we derive the identities. It is just not, oh, these are the identities, you use it like that. Okay? Questions? So we call this one as quotient identity. That is another Pythagorean identity. Next is this one. Before we divided by cosine. Now we divide it by sine squared. Okay? So what happens sine squared over sine squared?
Sine squared over 1.
Okay, very good. So that is 1 plus
1 over
cosine squared over sine squared is?
1 over. No.
Is it tangent or cotangent?
Cosine.
Okay, cotangent is equal to 1 over sine squared.
Cosine.
Cosecant. So it becomes 1 cosine squared sine squared cotangent squared, then cosecant. CSC squared meaning cosecant. Hello?
Yes.
Right? So if we are going to cotangent squared is a quotient identity and cosecant squared is reciprocal. So this is another Pythagorean identities. Questions? Alright? Okay, so that is why in your paper you have these identities. Okay, sure. Questions? Sarah, you have questions? Okay, let's have an example. Okay, here, we will apply now the identities that you have. So you have the paper there. Using the identities you now know, okay? Find the trigonometric value, right? So this one, number 1, if cosine squared is 3 over 4, what is secant squared? 4 over 3. Very good. Can you show it? Come on, come on, come on. Come on. Come on, sit. Like it. No, just do like that. Okay. Very good. So secant squared is secant theta is this one. Hello? Using the identity. Okay, how about number 2? Who can answer? Okay, can you try? Come on. Come on. If cosine theta is 3 over 5, what cosecant? Okay, I will just ask you a question. Like, what would identity would be used? What identity? The first, second, or third? The third one, right? We will use sine squared. What do you think? Reciprocal? We use reciprocal? We will use reciprocal. How about you? Reciprocal. How about you? What identity? Quotient? Quotient, reciprocal, or Pythagorean? This one, reciprocal. Cosecant is sine. Cosecant is sine. Right. If you are going to do the reciprocal, cosecant is, this one is sine, right? And this one is cosine. How can we have the cosine? Using the identities. I know we can solve this one using, like, for example, if this is cosine cosine theta, that will be 3 over 5. And cosine theta, that will be adjacent over hypotenuse, right?
Yes.
And from this, we could get the opposite, right?
Yes.
Like that. X squared minus a squared, like that.
Yes.
So we could have sine,
Yes.
right? But using the identities, how? What identities would be required to use?
So sine theta squared plus
Okay, so let's try. Sine squared theta plus cosine squared theta is equal to 1. Next,
sine theta equals 1 over cosine
you try. Just substitute 1 minus 3 over 5. have another solution. So let us see if we have the same. Okay. Let us make it. So if we have this one, I will just use sine squared theta plus cosine squared theta is equal to 1, right? So sine squared theta plus cosine is 3 over 5 squared is equal to 1. 1 minus, this is 9 over 25. So sine squared is just
It's
16 over 25, right? Okay.
and then sine theta is equal to 4 over 5.
Square root of
Oh, I forgot to square it.
And then sine theta is equal to 4
是我为什么
4 plus minus 4 over 5. Oh,
16. So sine theta is cosecant theta, right? So that is cosecant theta is 5 over 4. Oh, so, okay, so there you go. Okay? So could you write that one on your paper so that you will know? Yeah, we have the same answer. Okay, so in this lesson you are going to think what are the identities to be used, and you should be careful. Okay? But anyway, questions so far? So if you follow this one, we have the same answer. Very good, Carina. Is you don't know that difference. So in this way, you have to be careful. Okay. So can we go to the next?
yes.
Sure. No. No. Okay. Your way. Oh, you can I?
I'm following myself. Look, we have it. It's blue.
Okay, I will give you. If there will,
Why?
if you don't have any absent, I will pass.
Why do you? I don't see.
Ah, okay. Why you?
Yes.
There's a you because organizations. Reactions.
Okay. Okay.
个物理十八起家。
不是，我这是创历史新低了，造我这是经济起的这个。
Alright, can we go on now?
Yes.
Okay. Let's have another example. Okay, how about cosine 1/3 and we are going to find tangent. What are we going to do with this? Second cosine is, what are we going to use? Pythagorean? Reciprocal.
Yeah.
First is here. Yeah. Reciprocal, that would be 1 over, cosine is 1 over second. Okay, so that would be
That would be
1
1 over second theta, second 3.
no. We have some second theta is
Oh. Oh, yeah. Second theta is cosine.
so 1 over maybe 1 over 3. So second,
is 3. Yeah.
right?
3.
And then next, because we are looking for the tangent.
Oh, yeah.
Use the
use the Pythagorean tangent square theta equal sec plus 1.
what is the formula?
So this will be equal.
Okay. Tangent squared is equal to
Second square theta plus minus 1.
minus 1.
Yeah.
Okay? So we could have tangent squared theta, so we have here, so negative 3 squared minus 1. So tangent squared theta is 8.
Yeah.
So tangent to radical 2. Hello? Questions? So first we use reciprocal. We use reciprocal. Then next we use Pythagorean operations. Okay. Good. Let me see your notes. Try to speak English. As much as possible. English, please. Do you have questions then? You sure? It's very easy, right? Okay, can we go to the next slide?
Yes.
Alright. Okay, next is simplifying the derivative expressions. Okay? Simplify meaning this, like for this example, cosine x, we just have to do. I did not put like cosine x and tangent x, just like that, okay? So if we are going to have that one, meaning we are going to answer only one. So how we could simplify this one? So we'll just write. It's just cosine x, sine x, tangent x. Right? So if we are going to simplify this one, how we do? What do you mean by simplify? Simplify is like, say for example, 2 over 4, right? If we are going to simplify this one, that would be 1 over 2. Okay, so we make it simpler. So how we could make it simpler? Okay, so by this one, like the one that we had yesterday, so cosine x, right, plus sine x, tangent x is
Sine x over
cosine x, right? So it would be cosine x plus sine squared x over cosine x. So if we are going to have the common denominator, right?
Yeah.
Cosine squared x.
Oh, yeah.
Hello? And this is
This is 1.
1 over cosine x. And 1 over cosine x is secant x. Okay, so this we call simplifying. From this one to this. Okay, for letter B, how we could simplify the problem. So we must, if you are going to simplify it, the given is tangent. The tangent should be converted into sine and cosine. Okay, so for this one, we could have cotangent is right. Hello? And then we could have cosine squared x over squared x multiplied, right? Multiplied by 1 over, is this correct? Yes. Okay, say that. Okay. Because you said yes. I will just okay, so cosine squared x over sine squared x times 1. What is this? Pythagorean theorem. Did you see? 1 minus sine squared is equal to?
Cosine squared x.
Okay, follow? So cosine squared x cancelled out. So it becomes 1 over sine squared x. And 1 over sine squared x is sine is cosecant. So cosecant squared x. Answer this one. 55 minutes. 2, 4, 6. 6 points. Answer this one first. Okay, very good. That is 6 points. Let's